This next question has to do with something known as type hints or type annotations in Python. It doesn't work so well, at least what I want to do now doesn't work so well in Jupyter, so I'm going to do it in a regular old editor, and we'll see what happens. So let's assume I create this function, def hello name stir return 5. Then we're going to say here print hello of 10, 20, 30. So the question is, and actually I should add a shebang line here, just so it'll work so well. Yeah, there we go. So the question is, what will happen when I run this program? So let's run it. I'm going to run this program now from the command line. I'm just going to say here, hello.py. What do you think is going to happen? It's going to print 5. Now that raises some interesting questions, right? If you predicted it was going to print 5, then that's great. So the question is basically what's going to happen and why. So someone coming from a background of a statically compiled language, or even someone who's sort of been yearning for type checking in Python might look at line 6 and say, aha, so this function has a parameter name which must take a string, and the function itself returns a string. And yet we see that the function returns an integer and takes a list of integers as an argument and isn't complaining in the slightest. It's running, it prints out 5, all is good. And if I do it again, strangely enough, computers being somewhat deterministic, even very deterministic, I'm going to get exactly the same answer. So what's the point of these type annotations? When does Python pay attention to them, and how are we going to use them? So let's start off with type annotations are new in Python 3. They come after a colon, and they are 100% optional. Now, it's true that increasingly, I've seen a lot over the last year or two, people starting to use type annotations in their functions, in their classes, and that's a great thing. I must say I've become from a very big skeptic of type annotations to an increasingly less grudging and increasingly enthusiastic user of them. I really think it does help to both document the code and make it less potentially problematic. But Python itself is going to ignore these type annotations completely. Indeed, the objects that come after the colon can be absolutely positively any object you have in Python without exception. Python will ignore them 100%. So why do we have them? If Python's going to ignore them, why do we have them? And the answer is that external tools can use them. External tools like mypy. If I run mypy on hello.py, it is going to run our program. It's going to check the program. It's going to double check that all the places that we are passing arguments, all the places we are making assignments, all the places we are returning values are all going to follow the rules that we set out. And you see here that it says hello.py in line 7, incompatible return type. We got an int, but we expected a string. And in line 10 it says argument 1 to hello is incompatible type of list int. It expected string. In other words, Python's not going to do anything about these type annotations, but external systems, external programs that, like type checkers, sort of like mypy, can and will do that. Now, is Python at some point in the future going to include kind of, this type checking inside of the language? Hard to know. I'm a little skeptical, but it's hard to know at this point what's going to happen. But you should realize that type annotations are an increasingly important part of Python development. They're used in a growing number of places that use Python. But, the language will ignore them. And so it's not atypical for places that are using mypy to run it as part of their CI, their continuous integration system. It's not unusual to use it as part of the git commit hooks, that when you commit to git, that it runs a program double checking, and if there are any type errors or type annotation mismatches, then it won't allow you to commit your code to Git. All right, so there's so much to say about type annotations. This is really just scratching the very, very, very surface of it. But the important thing here to remember is that Python couldn't care less. It will ignore them and allow you to do whatever you want. Let me just finish this up by saying, let's make it work for real. So I'll say here, hello name, and here we're going to say hello world. Oops. And now, if I run the program itself, sure, it's going to work. Right? It'll say hello Reuven, or should at least say hello or hello world, right? But if I run mypy on it, now it should come out and say, hey, I don't see any trouble here. You're actually doing okay. No errors found in this file. So I'm going to allow you to, keep going. And obviously, if mypy were to find anything, here we go, no issues found in one source file, it would tell me in which line the problem occurs and which argument and which value is giving me the trouble so that I can then fix it as necessary.